Hi friends, welcome to follow up. In this video, let's have a look at problem 1143, longest common subsequence. This is today's daily challenge problem. Actually, this problem is very classic, so we're going to use this problem to practice dynamic programming. First, we're going to digest the requirements, and then we do the analysis, and finally we share the code. During the analysis, we want to emphasize a small detail. So with that said, let's look at the problem statement. So here we are given two strings. We want to find their longest common subsequence. So here it's a subsequence. This is to be distinguished with substring, right? So here we have three examples. In the last example, so there's no common characters in between the two strings, so the output is 0. So this is very special, right? So the second example, so the two strings are identical, so the output will be the length of the strings. So in the first example, it's sort of generic. So here we have ACE. So in this case, text 2 is a special subsequence of text 1. So overall, I feel that all the three examples are not that representative, but you can imagine one or cook up one with this problem statement. So here, let's see, the constraints are the following. The two strings have lengths bounded above by 1000, and both consist of only lowercase English letters. So with that said, we are ready to do the analysis. So here we are going to use tabulation. So if you have practiced quite a large number of leetcode problems up to this stage, so you should be very familiar with this pattern. So here I'm going to use a 2D table to represent the general term in the dynamic programming procedure. So here I'm going to use dpij to be the length of the longest common subsequence of text 1 up to the index I, right? So similarly, text 2 up to index j, right? So then we want to, update, right? So here, if we want to update, actually it's very simple. So you compare the characters at index I and j in the two strings. If they are equal, so actually this is what we want to return, right? So we can either match the characters at index I, j respectively. So the length will be dpij plus this common one. Or we have this one. If we do not, in this matching case, we do not match them. So we are going to have dpi j plus 1, dpi plus 1, and up to j, right? So but in both the two cases here, actually, because we compared with dpij, we add at most one character, right? So this one is always dominating the maximum. Actually, it's equal, right? So because it's one of the terms in the max, so it will be dpij plus 1. This is actually a small detail, but I hope that you can digest. If they're not equal, right, we just have these two terms. I'll just take the maximum. So that's the general case or general rule. So, but when we do initialization, so we can imagine text 1 start with some empty space or star. Well, the other text with some pound, as long as they're different. And then this way we can initialize the first row and the whole first column in the DP table to be 0. So this is actually very convenient. But you need to do some manipulations of shifting by 1 in the indexing. So with that said, I guess we are ready to write the code. So first I'm going to, I have already changed text 1, text 2 to be S1, S2. So this is just for the ease of typing. Then I get the length of the two strings, length S1 and the length S2, right? And then we are going to initialize the DP table. So I'm going to have, so we have m plus 1 columns, and then we have m plus 1 rows, right? Because we imagined, right, S1 is something like this. Let me write like this. S1 is say star S1, right? S2 is pound S2. So with that said, when we do this in size of table, so we already initialize the first row and the first column. They're all zeros because any characters in S2 it does not equal to star, right? Similarly, any characters in S1 does not equal to pound, right? So with that said, we are ready to do the DP update. So for I in range, so we start from 1 up to n, right? We write n plus 1 here. And then for G in range, so 1, m plus 1, right? Then we are going to consider the characters at index I minus 1, J minus 1 actually, right? So we want to see S1, I minus 1. If this is the case, then what we are going to do is to do this. dp ij equals dp I minus 1, j minus 1, and plus 1. This corresponding to this this block is this if block. Now let's look at the else block. So we're going to say dp ij equals max as dp I plus 1 j, right? And also dp I j plus 1, right? So this actually tells us when we are going to so here so here it's not just I minus 1, the j minus 1, right? So this basically tells us when we want to look at the element at index ij, so the one above and the one left are already known, right? So with that said, we just need to return the bottom right element, that is dp -1, -1, right? So this gives one solution format. We can do a test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. I guess this problem, for now, it's actually very straightforward. But for better practice, you can try all those ones. So the longest palindrome subsequence, actually we have videos for this problem. But this is a little bit longer, harder than this one, than the subsequence, right? So yeah, you can also try the other ones. So with that said, I guess that's it for the current video. Thank you.